In this video I'm going to have 3 sample calculations, one easy one, and then a not so easy, and then one that's involving scientific notation. And in most cases you don't even need a calculator. So to get started, I'm going to have here some memory joggers about the nature of division. 2 things, namely, the terms of division are only interchangeable in a very limited way. Consider this one here, 100 divided by 24 divided by 4. 100 divided by 24, that's 4. There are 4 quarters or 4 25 cents in a dollar. So there's 4. 4 divided by 4 is 1. What's interchangeable is the 4 with the 25. The first number is the dividend, the number to be divided. The 100 has to be staying at the front. You cannot start with a 4 or a 25 because it's not going to be 1. But the 4 and the 25, you can switch them up. So 100 divided by 4, that's going to be 25. 25 divided by 25 is 1. Or what you can do, instead of 2 divisions, you can go with 1 division and 1 multiplication. 4 times 25 is 100. 100 divided by 100 is 1. Okay, so the divisor must stay at the front before the division button is pressed on a calculator. Alright, the divisor must say the divisor. The rest of it is interchangeable with caution. Another fact that I want to point out is that every fraction is a division. So I have here 72 over 6 as in a fraction format. It's a division. 72 divided by 6, it's 12. You can break 72 up into its factors and 6 up into its factors. And the factors of 6 is 3 by 2 and factors of 72 is 12 by 6. So this fraction is the same as that one, but this one has multiplication because numbers in scientific notation kind of look like that. Like 5 times 10 to the power of 2. You know, there is a multiplication in scientific notation, and if you want to divide one scientific number with another scientific number, there is 2 multiplications and 1 division in it. So the top number, the 72, is the dividend. It has to stay the dividend, okay? The 3 and the 2 can trade places, and the 2 and the 12 can trade places, but the amount that they represent, their product, the 72, must be up top, or that must be the first number entered into the calculator. The 12 by 6 divided by 3 by 2 is the same as 12 divided by 3, do 1 division, and then just do 1 multiplication with 6 divided by 2. Now 12 divided by 3, that's 4. 3 divided by 2, that's 3. 4 by 3, that's 12. And the 3 and the 2 can trade places this way, or the 6 and the 12 can trade places either which way. 12 divided by 2 is 6, and 6 divided by 3 is 2. 6 times 2, 12. Either which way, it's 12, but you have to start with the 72, or the 12 must be a dividend and the 6 must be a dividend before divisions are done and before multiplications are done. So keep that one in mind. Alright, memory jogger. I know it's an adventure. The easy one, different bases. Okay, division with numbers in exponential format with different bases. For example, 5 squared needs to be divided by 2 cubed. Okay, those bases are different. 5 is not 2. So in this case, how you divide these 2 numbers is you have to calculate the subtotals for the numbers in exponential format. So 5 by 5 is 25, and this is divided by 2 to the power of 3 is 8. And then do long division or put it in your calculator. Let me see. Or you can do it just mentally. Let me see. 3 times 8 is 24, and then you have a remainder of 1, so that's 1/8 is what the remainder, or if you like, that's 3 1/8 is the final answer. And if you want decimals, of course, it's 3.125. There. Long division, yeah. Next one, so that's the simplest one. Not the simplest one, but that's the easiest one, maybe. Okay, work before division, work with the numbers from exponential format, make standard format numbers, and then just do a division. Now, next one, exponents with the same base. For example, 2 to the power of 9 divided by 2 to the power of, 4 divided by 2 to the power of 3. How about that? Equals. Alright, if we follow the same logic, it's gonna be roughly about the same thing. 2 to the power of 9 divided by 2 to the power of 2 to the power of 9, that's 512, divided by 2 to the power of 4 is 16, and it has to be divided by 8, and then you get an answer. So 512 divided by 16, that's 32, divided by 8, you're gonna get 4 out of it. Okay, so that's one way of dealing with this, that you rewrite the numbers in exponential format to standard format and then just carry on the operations that way. But that may not be convenient in all cases, especially when working with scientific notation. You don't want to convert them to standard format. That's the point. So there is a shortcut here, that 4 is the same as 2 to the power of 2. Now the result is in the same base as the dividend and the divisors. So if you look at the exponent number 2 in the quotient, how do you get 2 from 9, 4, and 3? What I have in mind is 9 minus 4 minus 3 equals 2. Okay, so there's your shortcut. I'm going to explain why this shortcut works. But 9 minus 4 is 5, minus 3 is 2. Okay, so that's a given. Where the shortcut comes from is 2 to the power of 9. It's going to take some place here. Is the same number as, I have to write down 2 9 times. So that's 2 by 2 by 2 by 2 by 2 by 6, 7, 8. Let me see, 2, 4, 6, 8. That's 2 to the power of 9. Okay, there's your 512. And this is being divided, and I intentionally write a fraction bar here, 2 to the power of 4. And I'm going to write it just here. There's 4. Now, like I said, if you have a fraction like so, just like here on the memory jogger, you can kind of take it apart a little bit as follows. 2 divided by 2 is 1. Okay? 2 divided by 2 is also 1. 2 divided by 2 is also 1, and 2 divided by 2 is also 1, and 1 by 1 by 1 by 1 is 1. So what you're left with is 1, 2, 3, 4, 5 pieces of 2's that are multiplied together. In other words, 2 to the power of 5 is what you are left with when you divide 2 to the power of 9 with 2 to the power of 4. And 9, not coincidentally, 9 minus 4 is 5. And no, things don't just cancel out and they don't just drop out. Okay? 2 divided by 2 is 1. And then when you multiply ones with themselves is 1. Okay, it doesn't disappear. It is just 1. Okay? So that's why you can just, when you divide, subtract the exponent numbers when the dividend and the divisor are in the same base. And that's the shortcut that we can use for the last one, super fast. Exponential notation. How about some fun numbers such as Faraday's constant, which is, I'm just going to write it here, F, that's not force, that's Faraday's constant, and I'm going to divide it by Avogadro's number. Avogadro. So Faraday's constant is 9.6 times 10 to the power of 4. Let's divide it by 6 times 6 point. Yeah, there are more decimal digits. You can do a better job. 6 times. Oops, that's not times. Where's my white at? 6 times 10 to the power of 23. Avogadro's number. When you do this division, it is the same as 9.6 divided by 6 times 10^4, 10^23. Okay, following the same logic as with smaller, easier to manage numbers. So 9.6 divided by 6 is 1.6 times 4 minus 23 is, oops, 4 minus 23 is negative 19. Yeah, okay. Negative 19. Alright. Just had a brain freeze there. So, this number, 1.6 times 10 to the negative 10 to the power of negative 19, is not coincidentally the number for elementary charge, either of an electron or a proton. So this can be a negative number or a positive number, either which way you look at it, but that's the skill of dividing with numbers in scientific notation form. If the bases are the same, you can just subtract the exponents. That's why in scientific formation the base is purposefully 10. So you can do these on the calculator easily.